All right, welcome everyone. For those who are already joining us, thank you for being so timely. For those that are not, we're going to give just a couple minutes here before we get started, and then I'll kick off and introduce myself and have Rolf as well, who's helping lead this webinar, introduce himself, and then we'll jump into the discussion. So just bear with us about 2 to 3 minutes and we'll get started. Thanks. Start by introducing myself, and then I'll pass it off to Rolf, who will be co-leading this webinar with me today, and I'll let him introduce himself as well. And then the structure of the webinar here will be to deep dive a little bit into the OpenADR standards, but also talk about the history and the evolution of those standards. And for those who are involved in different businesses that might be pursuing OpenADR or considering them, thinking about what are some of the opportunities and how do some of these evolving standards and the new 3.0 version cater to your business and unlock new business use cases and potential value for your business. So I'll go ahead and get started. My name is Spencer Borison. I help lead the US business for Codibly. Codibly is a 12-year-old IT services consulting firm that does software development and consulting work for companies across the renewable energy and e-mobility space. We're primarily based out of Poland, so offer a team of about 200 software developing resources and experts across this renewable energy domain, and then also have a dedicated team within the US to help with some of the North American clients. So happy to be here today. And we're also a contributing member of the OpenADR Alliance, which is why, in part, we've taken this opportunity to talk with Rolf. So I'll turn over to Rolf. Rolf, if you'd like to introduce yourself.
Absolutely. Thank you, Spencer. Rolf Bienert here. Some of you may know me already from other webinars, certainly just like Spencer as well. But I am the managing and technical director of the OpenADR Alliance, a nonprofit mutual benefit organization that has its headquarters in California, close to San Francisco, in fact. But the Alliance is, as a nonprofit organization, a more or less virtual organization based on memberships So pretty much everything is created and thought of by the members, like Codibly is as well. And we just tie these things together from the Alliance side, of course. And Codibly has actually recently been helping us developing the test tool for OpenADR 3.0 that we'll be also talking about today, of course. But I think, Spencer, you mentioned it already, right? We wanted to quickly do a bit of a history lesson, so to speak.
Yes, that's right. And I think as we kick off here, just in terms of the format for folks who are joining us, we've got a QA function in LinkedIn. You can comment within the LinkedIn page for this live event, and we will be doing our best to respond to as many of those questions as we can throughout this event. So you won't just hear us speaking back and forth throughout this dialogue, but also want to make sure that we're engaging you all for the questions that you have. So feel free to hop in. You won't be able to speak, but definitely to comment on the LinkedIn page so that we can try to take as many of those questions and make sure that this is engaging for you as well. But yeah, without further ado, yeah, Rolf, if you want to give us just a bit of an explanation. I know that OpenADR in some form has been around for almost 20 years, roughly. So I'd be curious to hear a little bit more, and then we can definitely dive
Absolutely.
into where we are today with this 3.0 standard.
Yeah, sounds good. And thinking about this, that reminds me, I was recently honored to provide one of the keynotes in New Zealand for their big electrical engineers association. And for that, in fact, I kind of dug out this chart again, which I actually hadn't used in a few years, because as you can see, it was meant to be much shorter there in the beginning, and now it's getting squeezed in towards the end. So we probably have to redraw that at some point. But yeah, like you said, Spencer, the idea of OpenADR, the concept is certainly not new. It came about in a grant project from the California Energy Commission. And when you have gray hair like me and used to live in the US, you might remember that energy crisis in the early 2000s in California, where due to some mismanagement of capacity, they literally had to turn off like cities or city blocks to just not run out of power, quite literally there. And after that, of course, the California Energy Commission, the state basically said, yeah, we can't have that, right? We can't have the powers being switched off. So we need another way of communicating between the utilities, or I guess in Europe, most folks call them the DSOs, and the consumer end, to do a bit of a balancing here, right? To have essentially the option to reduce the load. And at that point, it was really just about reducing the load. There was no, not so much solar, there was no batteries really, and things like that. So at that point, it was just curtailment, as we call it, to really, eliminate any of these outages there. So, and from there on, as you can sort of see here, this was put in place in like 2003, 4, 5, 6, when the first deployments were happening. And to be honest, a lot of these early programs, they're still running successfully in California. They haven't changed really there. So, but then we saw that kind of boom in the US, but also in other countries, with the economic downturn and the crisis there. The government in the US put a lot of money into the smart grid development, and there was 2007, 8, 9, 10, where we got a lot of different basically use cases and requirements, and we flowed that all into the concepts of this early OpenADR 1.0 to create then the 2.0 approach. And we wanted to put it beyond the small user group that they had in California with just a few companies and some utilities, but make it so that it really works for other states, other countries, really anybody. So the OpenADR Alliance was formed late 2010 to create the actual profile specifications, the testing and certifications and such. And then by 2012 and 13, we had the 2013 version of 2.0b ready. And since then, we have a little bit over 300 certified products now, and became an IEC standard in 2018, unchanged, basically taken over to the IEC. And since about, I want to say 2021, we have been thinking about 3.0, and we're just now kind of getting there. But I think we will talk about that more later in detail. So just wanted to give you that quick history here. So not a new concept, but now with 3.0, we'll see actually quite a few new things coming along.
Yeah, no, I think that's really helpful, and for those listening, so the 2.0 to 3.0 evolution is something that's of particular interest here, and I'm sure based on some of the industry conversations that we've been having, myself and Rolf, including at the NLIT conference in Paris this past week, it seems like there's definitely some interest in understanding the 3.0 standard, and so the timing of this webinar was really well placed to make sure that we can talk about that based on some of the feedback we were getting both before that conference and then in person in Paris last week. So, Rolf, I had read some materials and was curious. I guess a question in terms of where you're seeing OpenADR adoption. I know that, of course, based on the history you presented, the U.S. was the original market, but then also with the IEC, Europe has come into play in recent years, and I know that also Japan and South Korea and China to some extent. I'm curious if you can talk a little bit about, within those different markets, which types of companies are involved, and do you see future growth really being deeper penetration within each of those markets that are already your main players, or do you think there's other potential markets that are not yet adopting these standards or adopting them to a greater extent that might take a big step forward in the coming decade?
Yeah, definitely interesting question. I mean, a pretty broad field, I guess. So we can make it a quick discussion here. So, going back in that timeline, the initial low-hanging fruit, as we said in California, for instance, was the small medium business space. Really, as you can imagine, talking to individual households at that point was still a little difficult. Early 2000s, not everybody had either a mobile phone or a smartphone, and connectivity wasn't so well and stuff like that. It's kind of crazy. It's only 20 years ago, but quite some changes there. So small, medium businesses were a good target because, you have an office building that has already some building automation integrated, for instance, temperature control, right? Have maybe rooftop units that are more or less consistently running and such. And then on the other end of the scale, maybe even the food industry with refrigeration units in food chains and stuff. And that then really kind of changed fairly quickly, in particular with 2.0 coming along, because now things are moving in the cloud, right? So we have a lot of cloud infrastructure there where it's much easier to implement OpenADR, let's say, in a cloud than it would be to have it in an extra thermostat on site. Sure, you could do it. Thermostats are almost all connected to Wi-Fi these days, but still, most of the controls are happening in the cloud one way or the other. So we saw that coming a lot, where these thermostat manufacturers, and I shouldn't maybe only narrow it down to them, but also say any controls manufacturer for the building, right, moved into the cloud, right? And all of a sudden, now you open this up to these guys becoming, in a way, an aggregator, for better or for worse, I guess, where they can make the connection to the households, for the utility. So the utility can send an OpenADR signal to the thermostat cloud, and the thermostat cloud, based on previous settings, makes the connection to, Rob's house, Spencer's house, and so on. So we saw that starting in California, but then broadening everywhere across the United States. And like you say, Japan really accelerated because of the Fukushima disaster. They really needed to do demand response, so they pushed hard. So there, the market is still very much straightforward demand response to the aggregator as well. But they are experimenting also with to EV chargers to households and so on in Korea as well. And then, yeah, as you can imagine, 2018-19, that whole EV charging boom started, right? So since 2019, we probably added like 40, 50 companies that are in the charge point operator space, where they receive OpenADR signals to the control center, for lack of a better term here, and then use other standards, for instance, like OCPP and such, to the individual chargers. So really that space, if we want to mention like one of the most interesting spaces right now is certainly EV charging, and soon also vehicle to grid, right? The reverse way there, lots of capacity available, right, for this. And I think I saw actually a question pop up in the corner of my eye here. OpenADR, for instance, is also used actually in gas and in some instances water systems. California has obviously some challenges with water, so there were some discussions there, and a national grid in the Northeast and in the US uses it for gas in the winter, for instance. But I think looking forward, Spencer, part of your question was also like other markets, right? And really good question. It seems that virtual power plants have been, in huge discussions. And, for me, to be honest, with my OpenADR hat on, or in this case, shirt on, I guess, for me, that's all the same, right? Because it's a resource. And if the DSO or the utility can have some influence over whether it's taking energy, providing energy, or can maybe negotiate some prices and things like that, then for me it's a resource. But VPP, virtual power plants, is a big topic. And I think one completely different area that we are seeing, the starts of back in California, is the dynamic pricing market. So we are seeing more utilities being interested in having really like fully dynamic prices, not like fixed rates, right? Until a few years ago, dynamic prices was more like, okay, until 10 a.m. you pay something, until 1 p.m. you pay another thing, and then so on. So, but for that, you just need a timer, right? But now we're talking about dynamic prices that can change, all the time, and therefore it's interesting to convey that to the customer side, maybe also to appliances, to local networks like a Matter network, and so on. So there are some of these areas where we are seeing some I wouldn't say completely different markets, but different implementations, really.
Interesting. Yeah, no, that's it's a good perspective, and I was also struck when you mentioned around Japan with Fukushima, thinking about sort of what I would call a drastic, either public opinion driven supply shock, or some sort of geopolitical supply shock that necessitates demand response through a sudden drop in potential power if you're looking ahead. And I'm also thinking of examples like Germany with a plan to phase out most of their nuclear power and probably having some supply limitations because of that, or something like New York State as well, that are thinking about how they can start to retire some of their old nuclear generation across the state. But then also on the other side, thinking about places where we have extremely high adoption of EVs, for instance, like Norway, for instance, where we have extremely high demand rather than extremely low supply in the short term. and the need to better use those assets. And especially as you're mentioning with this vehicle to grid concept, being able to actually draw back power from all these different batteries that are distributed across the country, and to be able to leverage that. So I wonder, what are your thoughts on any of that, and if you think that that's potentially one way to think about this as well in terms of specific markets?
Absolutely. I think you're absolutely right. And really, that's what we see here in Europe happening, right? I'm the first one to admit that there is really no large scale demand response to a customer yet in Europe. And if I'm wrong, the audience, please correct me. I would love to know. But everywhere we go, we hear that flexibility, right? Demand response flexibility is needed, could help a lot. And it is in some areas, in Belgium, and actually you mentioned Norway, in Sweden and in Norway, it is already executed like a little bit higher up in the market. So there seems to be like TSO, DSO, right? Transmission to utility, congestion management, and so on. So that is already done, but not really in a larger scale down to the customer, really. And that is where we have to get to. And I think it is a leap for the utility. I'm not gonna lie, right? The utility is used to, and I'm saying that not negatively, but the utility is used to providing this critical infrastructure, but keeping the customer basically at arm's length, right? So you got your meter as your endpoint, and you use energy and you pay for it, right? It's a fairly straightforward business model, right? And it takes some time to get over that thinking, right? And think about a full system, right? That we are talking about a consumer, integrated system here, right? Where they're using maybe a lot of energy to charge the car, but at the same time they have that energy, like you said, right, to potentially help the grid for a short while, or run the house, of the car and things like that. But for that, the utility needs to really come up with these programs. And I think we are trying to educate on the opportunities, but we are not so deep like in all the markets. Maybe Codibly actually might be also in there and helping. And I think that's really a key thing. I come from telecom originally, and again, that ages me just like my hair. But when I started Deutsche Telekom back in Germany, the killer application was the fax machine, right? So everybody thought, oh, that's for the next 20 years the thing, right? And it really exploded from there, right? And it was the same thing. The customer would rent the telephone and get the telephone line, and you pay for the minutes, right? And that is all gone now, right? Now it's customer-owned equipment, and you're paying for the pipeline and not even for the actual minutes, right? So completely changed around that system, and I wonder if we will see something similar where a household, if we have a lot of renewables and so on, might not even necessarily pay for the individual kilowatt hour. So I'm now looking quite a bit in the future here, right? But maybe not pay for the individual kilowatt hour, but rather for the maximum pipeline, right? What is the maximum number I can use at any given time? Is it a 5 kilowatt, right? Is it 10 kilowatt or a 3 kilowatt? And if the house can balance that, they might get a really good rate for that. And the utility knows what is this baseline that I need across customers, right? Completely different, thought, obviously, for them. But since you mentioned it, I want to throw
Yeah.
this out here.
Yeah, no, I think it's an interesting one, and I know we've gotten one or two questions in the chat, so definitely encourage listeners to continue asking those, and I'll try to loop those in throughout the conversation here when I think it's topical to exactly what we're discussing. One thing I think we could shift to here, Rolf, just looking at the time, we're having a good conversation already, so I wondered if we could maybe shift a little bit towards this evolution of the standard itself now, and talking a little bit more about 3.0 And I wanted to maybe preface this section a little bit with just how I'm thinking about laying it out is for those who are listening, talking a little bit about what the 2.0 standard looks like. That's sort of the existing base case with OpenADR and what the actual certification looks like today. And then talking about what are some of the enhancements and additional features and capabilities that this 3.0 standard that's being rolled out now looks like, and also with this new testing tool that Codibly has been helping OpenADR to develop, how that's going to enhance and make easier the process of certification for companies considering becoming certified with OpenADR Alliance. So maybe we can start, Rolf, if you want to do the first part, I can take some of that second stuff. But if you want to start by just talking a little bit about, 2.0, what does it look like today? Those companies that have already implemented it, what was the experience like for them, both in terms of implementation and certification? And then we'll shift towards 3.0.
Absolutely. No, that sounds good, Spencer. And yeah, I mean, as you have seen earlier in the timeline, 2.0b is now 10 years old. So it came out in 2013, and the concepts were already older, 2010, 2009, coming out of these smart grid efforts. And of course, at that time, everything in smart grid controls, utility controls and such ran via XML code. So 2.0 was specifically also kept in XML format. And we used a SOAP exchange model. So for those not too familiar with it, I'm a layman there too, so don't quote me on it. But it was basically a slightly older way of doing web services, and what that did in OpenADR 2.0 was that it basically fused a certain business logic into the actual protocol exchange here. So when we would test 2.0b, we would have to run a separate unit here. Like on a laptop, for instance, we would run software that would emulate for instance, the virtual top node, the server, or the client, depends on what we would test. And then the message exchanges would be basically tested here. And we're doing something similar today, but we'll get to that. So it was pretty clear, you had to read the message correctly, you had to respond, and so on. And pretty much any 2.0 client system, so on the customer side, would need to implement everything, because only that way we were able to say, now you're actually really okay to receive any type of OpenADR signal without kind of choking on the message itself, even if you didn't quite support some of the responses, like metering, for instance, and such. And Spencer, if you want, I'll go a minute here into the transition. So what our thinking was.
Yeah, I think that would be good. And
Yeah. Okay.
understanding the
So
evolution, we can get into it.
yeah. So then over the last, at that point, maybe 7, 8 years, we had collected a number of items that we received feedback on. On one hand, for instance, some functions that nobody ever used, that were initially put in because it was thought to be a good idea for demand response applications, but really nobody used them. So we in fact dropped them out of 3.0. Then we got additional requests for specific signals, signals where you could easier, for instance, manage capacities. We have a way to also convey volt-var curves if that is something that's needed, and things like that, and a number of other things. But then I think one of the most common questions I received over the last, I would say, 4 or 5 years was, hey, is this available in JSON? Like all the developers, right? They are not used to XML code anymore, and things like that, right? So the question was JSON. And so eventually we said, well, we don't want to break 2.0b. It's out there. We have 300 products that don't need to change. There's nothing that certified products have to do. They can just remain in place. We fully expect a lot of the deployments to just continue as they are. So there's really nothing that they need to do if they don't want to go to 3.0. So existing utility programs will probably continue to work. And in the near future, any servers that come out, new commercial servers, will actually need to support 2.0 as well as 3.0. So a little bit, the concept for us is a little bit like the mobile phone carriers, right? So the mobile phone can if it only can do 3G, that's fine. The carriers still need to support 3G even if they do 5G now. So that's the idea here. And then we said, well, if we already do JSON, then well, maybe we just do the full step and make it a REST API, right? So that of course was a bigger a bigger step in a way than just updating the code, the XML, and maybe switching to JSON. That would have been maybe another profile like 2.0c. But we said, no, since it's REST API, we better call it something different so it's really clear. And so we made it a REST API and really compressed the code here. The implementation will be much, much easier. So that's really one of the biggest features aside from some of these added functions.
And Rolf, maybe one question would just be for those members of the Alliance already who've implemented the 2.0 standard. I know that you mentioned given the interoperability, there's really no requirement. I guess is there a case in your mind for folks wanting to upgrade in the near term from the 2.0 to the 3.0 standard, or is it one of these things where you view it as more of a net new customer to the Alliance would be thinking about not doing the 2.0 and instead getting the additional benefits from the 3.0, and then in the future that would be just naturally starting to become the standard?
Right, and I think it's somewhat of the latter comment you just made, right? It will be a natural transition, I think, because initially, as mentioned, I mean, there are I believe now over 150 or 200 programs out there that use OpenADR, and they all run on 2.0, and they add resources all the time. So there's really no reason to change something there. We do, however, see already, coming. I mentioned earlier these dynamic price discussions, right? I see coming out of California, for instance, some of the utilities there that are very long-term OpenADR users saying, hey, if we want to really enable every consumer to get a price at all times, then it might make way more sense to add 3.0 to our existing OpenADR server, because then the end node that just receives the price, so that does nothing else, right? So we're not talking about an elaborate back and forth communication here with a charge point operator or something like that. It's just either an app or an appliance or something that wants to know what is the current price, right? So funny enough, so actually not doing something more complicated, but rather doing something simpler, actually, it might make sense to use 3.0, because then it's much easier for manufacturers to make these price receiving systems. So we are seeing that happening. And then, like you said, I mean, I think it will be a natural transition. And I mentioned that to some folks last week at NLIT, that I'm almost thinking it will be more of an outside of the US coming inside, right? So because you mentioned it as well, kind of a new user, we're talking to Sweden and Norway. These guys have written OpenADR in recommendations for flexibility programs. So if they're just starting with that, they might as well look at 3.0, right? Is it mature enough? Does it work? And so I think we will see it coming more from the outside back to the US, so to speak.
Yeah. I think it's a good thought, and one other thing I would mention in terms of Codibly's involvement as well, and so an area where I also see value is in the implementation itself. You sort of alluded to it, that it's a little bit more of a simplified and really focusing on those capabilities that are of the most value to participants within the alliance. And I know that Codibly has been helping support OpenADR directly with developing this testing tool for the 3.0 version, and maybe I'd just spend a quick minute on that. So basically, and Rolf, definitely feel free to hop in if I miss any details. But our team's been supporting you now for a few months as you've been working towards the release of this 3.0 standard. And as I understand it, being more on the business development side myself, so I know neither of us are developers ourselves, so we won't go too granularly into the technical details. But really, what this is meant to be is a way to make it easier for companies to be able to implement this 3.0 standard, but also to be able to do some internal testing whenever they want to, as many times as they want to, and to be able to get the results of those tests to see where they're still having issues with the implementation, and to get that feedback from the tool, both from the virtual top node testing perspective, which is more of like the utility control server, if you will. So, what would be communicating with your devices, or from the virtual end node perspective, which is those devices, and what would be receiving and responding to those signals that the utility would be sending. So, you can change hats within the testing tool to be able to be testing from the VTN perspective or the VEN perspective. But you can also get this real time feedback in terms of running that test and understanding where you're failing and which failures you're getting details from, and being able to understand those. And then ultimately, when you are ready for the certification itself, you're able to use that same tool with the different module, which is more of a certification module, which is to go through that test and send the results to the certifying body and the administrator, and then that administrator would be able to approve and review and validate your certification. So it's all very seamless and very user friendly, and I think makes it a lot easier to actually go through the process of completing that implementation and achieving certification for compliance. Ralph, I'm not sure if you would
Yeah.
add anything else around the test tool.
Yeah. I mean, I think very well said, Spencer. I think you covered most of it. Maybe just also to kind of reiterate from the previous version again, right? As I mentioned, for 2.0, it was a test tool. You had to basically download, you had to install on your machine, got it going and setting everything up. I mean, again, for developers, it's not rocket science, but it is a separate mechanism here. Whereas with this tool here that Spencer outlined, it will be something that our members can actually easily, online. It's hosted right now on Amazon Web Services. When they are logged in to their membership account, they can easily obtain a license, buy a license for a pretty good price that really just covers maintenance, and get started with the testing. Since it's all web services, it's all right there, right? So that should really make it much easier, and that's really all I would add. You already outlined it pretty well.
Great. So I'm looking at time, and I'm thinking maybe about 5 more minutes here for those listening. I think we had ticketed this as 35 to 45 minutes, and we're coming up on about 35 to 40 now. So I have one question from the chat that we've not yet answered, and Rolf, I think this one might be one that you've got a better perspective on, which is from Irene. I hope I'm saying that correctly, and it's basically asking if there's a plan to extend the standard of OpenADR or any of the logic or perhaps some of the capabilities beyond the energy sector. If there's any other sectors where you see this being increasingly relevant, and I think with some of the aggregation and the communication between decentralized devices, there may be, but I'm not sure what strategically you guys are thinking about there.
Yeah, a really good question. And to be honest, as I mentioned, I'm a telecom person, and now know a little bit of the energy side of things. So I would be open for discussions here where I have seen it. I mentioned it briefly earlier. I mean, gas is still energy, obviously. That's a different story. But water, right? Water supply can be an issue, and we have seen something like this when you start having limits in the supply of the water. California faces that a lot. Other areas, are getting drier and drier these days. I can see that water facilities would be sort of the next logical step. And we actually have seen specification downloads from probably, I want to say, 5 or 6 water facilities over the last year or two from totally different areas. One from California, and then I think recently one from somewhere in Europe. I'm forgetting right now. So I think the water would be interesting. Other than that, yeah, I would be happy to learn where we could reach out to personally.
Great. And maybe one other quick topic. I don't want to open a whole can of worms here, but I was
We'll
sort of
try.
curious your thoughts here in terms of, I know looking across some of the major markets where you operate, California as a great example. There's also other standards outside of OpenADR that would allow you to accomplish similar goals in terms of compliance with some of their communication programs for demand response. So I'm thinking in California, for instance, California Rule 21 and the acceptance by the state that you can implement either OpenADR 2.0 and probably in the future 3.0 to achieve compliance, but also have the option for this IEEE 2030.5. And I'm curious, Rolf, when you're talking to folks, some of the things that I identified as ways that you would consider choosing which is right for you and which one you want to move forward with between those two and potentially others. My understanding, having done projects with clients on both sides, is that this testing piece is actually something that is a significant advantage with 3.0 versus IEEE 2035, where you have to actually go to a testing authority and work with a lab to achieve certification, and that can actually be $10,000 to $20,000 and take several weeks just to achieve that certification testing result for IEEE 2035. And then also, I guess, through the OpenADR Alliance, I'm sure that you receive more support and opportunity to connect with other industry peers that you wouldn't receive from IEEE 2035. But I'm curious your thoughts on how you contrast OpenADR from another standard like IEEE 2030.5.
Absolutely, yeah. Thanks for remembering that. I think we wanted to talk about it, and I think what you mentioned is more on the mechanics, on how to get certified and stuff like that. And I'm shocked to hear that this is so expensive, but that's a different story. But I think OpenADR and 2030.5 don't really do the exact same thing. So I think there is certainly a coexistence in some areas, and in some specific scenarios, 2030.5 might be better. To be honest, I'm more of the opinion, of course, again, having my OpenADR shirt on, but that we might even see a concatenation here, right? That we see a connection, that we have OpenADR, coming down from the utility with more like objective messages, and then 2030.5, for instance, being implemented on the inverter, being controlled by some kind of an aggregation point in between. And the reason I say that is that people always, I think, confuse, for instance, California Rule 21 and demand response or flexibility, what OpenADR does, right? So we're talking about actually two different things here, right? On one hand, we are talking about adjustments made to the grid code settings of inverters. So with other words, for those that come maybe from telecom, like myself, so any inverter that's feeding back, and again, cut me some slack here, any cable that's thicker than this is not really for me, but any inverter that's connected to the grid obviously needs to have specific settings in order to, first of all, work properly, but also not to mess up the power quality in the grid, right? So basic settings, clearly, right? We're both in Europe right now, 50 hertz, right, versus 60 hertz, 230 volts or 240 or whatever, where depending on where you are, 220, 230, 240 volts versus 110 volts. These are very basic things, right? So they don't typically change, of course. But then there's a whole host of other mechanisms in there, starting by pass-through frequencies, voltages, and so on. You know, at what voltage does the inverter need to cut out? You know, for safety or other reasons. What frequency and so on, and then also and I briefly mentioned that earlier, like volt-var curves, you know, where how like the reactive versus the active energy flow is set up. So that there's a whole host of different settings in an inverter. And these settings, I mean, again, all inverters have these, all better inverters, I should say. You know, maybe not the 3995 one, but any inverter that you're technically allowed to connect to the grid have these settings. And often they used to be just accessible at the inverter. There was some, you know, Modbus interface that you plug in, or nowadays probably most of them are accessible via the internet, via some interface, some control interface. I have a Victron inverter in my house, so I can basically either connect a Modbus cable to my laptop and talk to it via a USB interface, or through their web-based management system. You know, I can technically make some changes there. But now the idea here is, and sorry, we did open a can of worms, but the idea here is now that you're opening up these controls to the utility, right? So that's California Rule 21 and the common requirements for inverters there. So these things are opened in these inverters for external control, right? And there is a requirement in the US, I think in the 1547 standard, that any inverter needs to be somewhat controllable, right? So where I always like to cut in though is that doesn't necessarily mean that in the end of the day, all utilities would want to control all individual inverters. I mean, personally, I think that is as crazy as it sounds. You know, if you have thousands, hundreds of thousands of inverters there and the utility trying to control them all, well, let the audience decide on that. But that's where 2030.5 really shines, right? So having 2030.5 has exactly that feature set to control these numbers. And yes, with that, of course, it can also turn on, turn off some stuff, you know, but again, OpenADR works completely differently, informing it, motivating the customer side to have activity changing, right? So that's why I think, you know, they will coexist. You know, there's a different reason why you would use 2030.5 if you really need to feel like you have to adjust all inverters. Or again, you know, what we have seen in many other programs as well is that there will be kind of a middle ground, right? That the inverters will be able to make all these adjustments using something like 2030.5, and then that there will be an incentive message or an objective message that might say, hey, if you're operating a lot of inverters, we need you to change these grid code parameters in a certain area. And then you leave it to, you know, the customer equipment to actually do it, potentially over 2030.5. So I hope that wasn't too complicated, but this is where how I see it, that really
Yeah.
people kind of mingle this together, where we are talking about two different use cases.
Yeah, no, no. I think it's helpful to differentiate, and I appreciate that context. And I think just looking at time here, so I think we're going to wrap up here. And for those who are listening, appreciate you making it to the end. Those that did not, I know we had a variety of people hopping in and out based on schedules, so we'll be able to share this recording, so please reach out to the Codibly team if you'd like to access it, and we'll make sure that it gets to you. And I want to thank Rolf for taking the time today to join the webinar and to share his perspective. I think it was an interesting conversation and excited to see where the 3.0 standard goes with the OpenADR Alliance and how that continues to drive greater demand response and flexibility across the US, across the rest of North America, Europe, parts of Asia, and hopefully globally as well as we look to continue to expand. So Codibly is glad to be a contributing member of OpenADR Alliance, and we're excited to see where our continued engagement can go, and appreciate everyone taking the time today. And yeah, I think we'll close there. Thank you all.
Perfect. Yeah, thanks for having me on. Excellent.
All right. Take care, everyone. I think we're going to close now and hope everyone has a nice rest of the day.
Take care.